Hello, my name is Jim Walters and I'm the Senior Quality Test Engineer on this new product. This is called our IntegraVision Power Analyzer, and today I'm going to show you some of the interesting features related to this product. And so the first thing I'm going to do is show you the voltage, current, and power waveforms for a LED light that I have being shined through a fluorescent tube. And so this particular configuration consumes very little power, and so I want to show off the power consumption. And then when I'm done setting up all the measurements, I want to show you how easy it is to capture those waveforms, email them to your email folder, and then analyze them after you've captured the waveforms. So let's get started here. So currently I have a voltage, current, and power waveform coming from this fluorescent light. And the AC power is coming out of the wall, going through a inverter, converting to DC and powering the LED strip down the back. So you can see that currently I have the frequency set to the frequency of the waveform is 60 Hertz, which is what comes out of the wall. And I have the RMS of the AC waveform. It's 61 milliamps. And the real power is down here, and that's 2.8 watts. So pretty low power consumption. So the next I'm going to add an additional waveform to show you how easy it is to add new measurements. So you could add a measurement for either voltage, current, and power. So I'll go to voltage first, voltage 1. And then I'm going to select a type of measurement, and this time I'd like to know what the RMS is of the waveform. So I can go up here and find the ACR RMS voltage. I added that, and now you can see that the voltage has come up over here. The AC RMS is 120 volts, which you would expect coming from a wall power. Next thing I'm going to do is show you the save feature. So if I can save multiple ways. So one, I can save this bitmap of this front panel screen. So to do that, it's very simple. You press save and then email. And I've set the email up with my mail server and a name of the file. So it's all set up. Just press save to email, and it says it's saving. And as quick as that, the screen capture is now in my Outlook folder, and I'll open that up in a moment. Now that I've saved the bitmap, I do notice some anomaly on the screen, and I think it's related to low-cost AC to DC converter. But if you watch the screen, you can see a spike in the current occasionally, and I'd really like to understand what's happening. So we have this great feature that you can trigger off of some event. So I'm going to adjust the trigger just above this peak here to capture the larger glitch that I'm going to see. So I'm going to move the trigger up here, right above there, and now it's capturing every time we see that big burst of current. And so what I want to do is capture this waveform, and I'm going to, instead of saving a bitmap this time, I'm going to save the raw data that we capture. And so when you save the raw data, you could select how many points you want to view. And then I will send that raw data to my email account and then open it up. And then I could use MATLAB or Excel to really dig into the data set and find these anomalies. Okay, so here we go. So the first thing I'll do is change the settings. And this is defaulted to 2,000 points. So I'll get a little bit bigger size. Let me go with 5,000 points. Enter. Okay, so now I have this set to save CSV data with 5,000 points. And I'm going to press send to email. And as you can see, it's saving. And now that data for all of these three waveforms has been sent to my email account, and we'll open up that file and take a look at that data now. I have my email open now, and I see that I've received an email from our IntegraVision Power Analyzer. So let me open this up, and this first email contains a bitmap, and when I open the bitmap up, and there you can see we've captured the front panel, and all of the measurement selections that we've made have also been captured. So you can see that we're measuring 60 Hertz there. The real power down here is at 2.9 watts. We have the maximum current, and we have the AC RMS of the voltage. So you could add more measurements and you would capture those also. So pretty good. You could put this image into your reports. characterize something, and save it for future reference. Okay, so the next email I'm going to show you is I've sent myself the CSV data, which is a series of points. And so I've imported this into Excel, and you can quickly make a plot of this just by clicking on a line. And here you can see I have the voltage waveform, I have the current waveform, and I could zoom this in and make this bigger. And there you have it. So I have the voltage waveform. You can adjust the scaling on these. Right now I'm showing voltage, current, and power. The scales should be adjusted a little bit to spread out the waveforms. But I've captured the waveforms, and then I can blow these up and look for the glitches. So that concludes the video. So today I've showed you that I can capture a waveform. I can use the built-in measurement capabilities of the waveform, save those using email, and I can save both the image, the front panel image, and the raw data for post-analysis. Thank you very much for watching this video.